Here we will talk about the grouping method for factoring. I refer to this as the AC method of factoring because as you see for step 2, it says choose factors of the product AC that add up to B. So our first step will initially be to multiply A and C together. But I want you to go ahead and pause the video and read over the guidelines and then resume the video as we look for number 96, the factors that make up this trinomial. Now, as we saw previously, this trinomial can be factored using the trial and error method. We will quickly do that to show that you can always rely on trial and error, but to show the guidelines for the AC method will show you that you will always be able to rely on a step-by-step process that will get you to your factorization if, in fact, that trinomial is factorable. 2x squared plus 5x plus 2. Again, trial and error says think of the factors that make up our coefficient of A and the coefficient of C here, the A and the C value. Notice that for trial and error, we're working with A and C, and for the AC method, it starts off by multiplying those two together. We're trying to find products and combinations between A and C. So two numbers that multiply to give you 2, 1 times 2. And because 2 is prime, the only other one is 2 times 1, so we'll leave that as our pairing there, 1 times 2. Same thing here for this plus 2. 1 multiplied 2 will give us the positive 2. Now we see here that this middle term is also positive. Because all of our terms are positive, our factors and our terms that are in our binomials will all be positive. We don't have to worry about any negatives because this isn't negative, this isn't negative. So we're going to work with 1 and 2, 1 and 2. What does this 1 and 2 imply? Well, what multiplies to give us 2x squared? With coefficients 1 and 2, this is x times 2x. We see 1x multiplied 2x. With multiplication, this is 2x squared. So our binomial product here, when factoring this trinomial, the first terms doing FOIL method in reverse, x multiplied 2x. Those would be the first two terms for each of the binomials. Now here are the real numbers that multiply to give us 2, which means they are going to go in these spots. The 1 and 2 are understood to be positive, so it will be plus 1 and plus 2. Now, which place does the plus 1 go? And which place does the plus 2 go? Well, we'll use trial and error to figure that out. Let's start by writing plus 1 here and plus 2 here and see what we get. Product of the first terms, f and FOIL, x times 2x is 2x squared. The O, x times 2, or 2 times x, is 2x. 1 times 2x, well, anything times 1 you get back itself. 1 times 2x is 2x. If you combine 2x and 2x together and they're both positive, that's 4x. 4x is not 5x, so we can stop here. Now let's consider switching the positive 1 and positive 2 by writing x plus 2 and 2x plus 1. Again, x times 2x is 2x squared. X times 1 is 1x. 2 times 2x is 4x. If I have 1x and 4x, that combines to give me 5x's. 5x is my middle term, and of course to confirm 2 times 1 is in fact 2. So we have our correct factorization. The factors x plus 2 and 2x plus 1 multiply to give us our trinomial, 2x squared plus 5x plus 2. But that's the trial and error method. We don't want to use the trial and error method. We want to use our AC method for factoring. So we go back to the PowerPoint. Keep in mind, x plus 2 and 2x plus 1 are the factors. But let's get those factors using the AC method and see how, just by following these steps here, an algorithm, an everyday occurrence. We all follow algorithms every single day. Wake up, brush our teeth, go to school, go to work, go to gym, come back home, eat, study, go to bed. An algorithm. Follow the steps, follow the process. Same thing here. First, start by writing the trinomial in standard form. For 96, we have our trinomial in standard form. Largest exponent first, followed by the next largest, etc. Step 2, choose factors of the product AC that add up to B. So we're going to stop here at 2, and we're going to go to the full screen. What does it mean by AC and B? Remember that the coefficients are A, B, and C values. AX squared plus BX plus C. So here, A equals 2. We have to see this in standard form in order to determine our A, B, and C values. B, BX, so B is 5. And our constant is always C, so that's 2. AC method says first multiply together A and C. A times C is 2 times 2, and 2 times 2 is 4. Step 2 says find two integers whose product is AC, whose product is 4, and whose sum is equal to 5. This is our general process each time. Find two integers whose product is AC and whose sum is 5. So in our heads here, what numbers can multiply to give us 4? What two numbers will multiply to give us 4 and will add at the same time to give us 5? We see here that 2 times 2 is 4, but 2 plus 2 is 4. That's not 5. Are there any other factors of 4, any other numbers that multiply to give us 4 integers that will add to give us 5? Well, what are all the factors of 4? We have 2 times 2 and 4 times 1. 4 multiply 1 is 4. 4 plus 1 is 5. So for step 2, we found those integers. When using the AC method for factoring, if you get to step 2 and you cannot find these two integers that multiply to give you AC, that will add to give you B, whatever those AC and B values are, if you can't find these two integers, here we did, 4 times 1 is 4, 4 plus 1 is 5. If you can't find those two integers, if it's impossible to find two integers to do so, it tells you that your trinomial is not factorable, that your trinomial is prime. That's the fun thing about using this method here. If you want to go through the trial and error method, you would have to go through each trial, each process, each combination of factors to determine whether or not it is factorable. Here, using the AC method, ask yourself this question here, and if you can't find those two integers, it's guaranteed that it is not factorable. We did find these two integers, so we've guaranteed ourselves that this trinomial is in fact factorable. So what are we going to do here? Now that we found those two integers, step 3 says use these factors to rewrite the middle term as a sum or difference. Using 4 and 1 to rewrite 5x. Well, 5x using 4 and 1, 4 plus 1 is 5. Therefore, 4x plus 1x equals 5x. That's why this is going to be significant, because just as before when we use the FOIL method, we need numbers that are going to multiply together across the binomials in such a way that their like terms will combine to give us the middle term. We found two numbers that will multiply together in such a way that they create like terms that will give us this middle term. Again, we're just reversing the FOIL steps. What do we do now? This 4x plus 1x, because it represents 5x, we are going to substitute this in to our trinomial. Two x squared plus, what is 5x? 5x is 4x plus 1x. And then 5x plus 2, we're just going to write now our plus 2. So we've rewritten our trinomial as a 4-termed polynomial. Where does this look familiar here? This first term is the result of multiplying together the first terms of binomials. Here we have our outer product, here we have our inner product, and here we have our last product. So how can we take these 4 terms here and find our two binomials that multiply to give us that trinomial? Remember, we already found it. We already know what those two binomials look like because we had our trial and error method that showed us exactly how this factors. But here's what we do here for the next step. Let's go back to the PowerPoint. Step 4, group and remove any common monomial factors from the first 2 terms and the last 2 terms. In other words here, for the 2x squared plus 4x, we're going to group them together. We're going to work with just those two together in a grouping, and then the x plus 2 we're going to group together. For the first grouping and for the last grouping, can you find a greatest common factor for these two terms to move out? And for these two terms, can you find a greatest common factor to factor out? I'll give you a moment there. I'm also going to erase. For 2x squared plus 4x, just looking at these first two terms here, if you had a polynomial 2x squared plus 4x, what do you see that's familiar or it's similar for both of these terms? Both terms has the x, so we can factor out one factor of x. What about the coefficients 2 and 4? Well, they're both even, right? 2 times 1 is 2, 2 times 2 is 4, so there's a factor of 2 present as well. So factoring out a 2x from the first two terms, if we factor a 2x out of these first two terms here, 2x squared, factor out a 2x, well that 2 is right there. There's two factors of x here, but now there's 1. We leave behind one factor of x. As we see, 2x multiply x is 2x squared. Now 4x, but the x gets factored out there, and then this 4 gets a 2 factored out, or in other words, divided out. 4x divided by 2x is 2. And again, as you see here, a positive 2 multiplied 2x is positive 4x. So we've taken care of this first pairing here. We factored out the greatest common monomial factor, which is 2x. We leave behind a binomial factor, x plus 2. How do we take care of this positive x plus 2 over here? What is our greatest common factor for just these two terms? 1x plus 2. Well, this 2 does not have a variable x, so we cannot factor out an x. Looking at 1 and 2, the greatest common factor for those two numbers is 1. So I can only factor out a 1 here, and that 1 is understood to be positive. Again, the greatest common factor for these two terms is simply 1. 1 is positive, so we write plus 1. When you factor, introduce parentheses to determine what you leave behind. Well, if I have an x here, which is understood to be 1x, and I factor out the 1, I leave behind an x. In other words, when I factor out a 1, I don't change the terms. I have a 2 here, but I factored out a 1. What happens when I factor out a 1 from 2? 2 divided by 1 is still 2. This 2 is understood to be 1 times 2. I pull this factor of 1 out. I still leave behind this factor of 2, which is positive. In other words, you see here for x plus 2, when I factor out a 1, I still leave behind x plus 2. But what do we see here now? For this first term here, I have the product of 2x and x plus 2. For this second term, I have the product of 1 and x plus 2. So each of these two terms here has a common factor. It just so happens to be a binomial factor. But binomial factors can still be factored out because they're multiplying. We can factor out common factors. In this case, we factor out x plus 2. So the x plus 2 goes out front. This x plus 2 goes out front. Introduce parentheses to determine what you leave behind. If this x plus 2 gets factored out, I leave behind 2x. If this x plus 2 gets factored out front, I leave behind a positive 1. So we see here the factors that make up our trinomial 2x squared plus 5x plus 2 are the binomial factors x plus 2 and 2x plus 1. Because as we see, x times 2x is 2x squared, x times 1 is positive 1x, 2 times 2x is positive 4x, 2 times 1 is 2. And now we see here at any time we can take these two middle terms, 4x and x, and combine them back down to give us the 5x for our simplified trinomial. We just simply reversed those steps, started with our trinomial, rewrote it as the 4-termed polynomial that we get as a result of the FOIL method. Again, how do we go from the trinomial to 4 terms? We just had to use that AC method to determine how do we want to rewrite the 5x? What were the outer and inner products that combined to give us 5x? In order to find those outer and inner products, we have to find the two numbers that multiply to give us AC that add to give us B. That's 4 and 1. And now using our grouping factoring, grouping the first two, grouping the last two to find a GCF of 2x, leaving behind x plus 2, finding a GCF of 1, leaving behind x plus 2. The common binomial factor x plus 2 moved out front, leaving behind 2x plus 1, therefore having our two binomial factors x plus 2 and 2x plus 1. 15x squared minus 11x plus 2. We want to factor the trinomial by grouping. We do so by using our AC factoring method of grouping. Looking at the screen to the left, if you need to pause there again to follow the steps to factor before you watch the video, I would strongly encourage you to pause now, work through it. And of course, if you have your binomial product, you can always FOIL through to see if you get back with the trinomial you began with. So we'll go ahead and get started here. Noting that we do have our trinomial in standard form, ax squared plus bx plus c, where a is equal to 15, b is equal to negative 11, and c is equal to positive 2. We get started. The product of AC in this case, 15 times 2, is 30. We want to find two numbers, find two integers that multiply to give us 30, and they will combine to give us negative 11. So what can we get there? Well, the obvious here, 1 times 30, but 1 times 30 can in no way combine to give us a negative 11. What about 2 times 15? 2 times 15 is 30. 2 plus 15 is 17, but notice they have to combine to give us a negative. They multiply to give us a positive. They combine to give us a negative. Remember, what happens there? If this number is positive and this number is negative, that means these two factors have to both be negative. Two negatives multiply to give us a positive. Two negatives combine to give us a negative. So these factors here for number 2 must be negative. Negative 1 times negative 30. Just thinking about all of our factors for 30 that are negative. Negative 2 times negative 15. You see the pattern there. I'll give you a moment to pause and write up all the factors that make up 30 that are negative. Negative 3 and negative 10. What about negative 4? Can 4 divide into 30? No. What about 5? 5 times 6. So negative 5 times negative 6 is positive 30. Do any of these pairings combine to give us a negative 11? Well, that's negative 31. That combines to give us negative 17. Negative 3 and negative 10 combine to give us negative 13. And lastly, there, negative 5 and negative 6 combine to give us negative 11. So we found two integers, negative 5 and negative 6, that will multiply to give us positive 30, and they will also combine. Negative 5x will combine through addition with negative 6x to give us negative 11x. So we found those two integers. Therefore, we are guaranteed this trinomial is factorable. So our next step is to use those two integers, negative 5 and negative 6, as we saw, to rewrite the negative 11x. We had the minus 5x and minus 6x. And we see there that will combine to give us minus 11x. So we have not changed our expression. We are just trying to rewrite it and manipulate it in such a way that we can expose this expression as the product of factors. That's our idea here. That's our end game. Next step here says that you have our four terms. So group together the first two terms, group together the last two. So you ask the question, what if you switch these two terms? What if you would have written minus 6x minus 5x? You would be okay. Fortunately for us, addition and subtraction is also commutative. You can move around these terms. You could take the 15x squared and move it to the end and just write plus 15x squared if you want to. But we want to have it in this order so that now we can group it this does not matter. If you want to write the minus 6x first, you can, and you can write the minus 5x here. I just note that if you write the minus 5x here, the minus 5x will not have anything in common with the 2. However, I see that this 6 and this 2, they're both even numbers, so I know that I can at least factor out a 2 because they're both divisible by 2. Likewise over here, both of these terms share the common x, but also 15 is a multiple of 5, right? Because it's 5 times 3. So I know that I can factor out a 5 here along with the x. So let's get started there. Counting my 5s, 5, 10, 15. I counted 5 3 times to get 15. Oh, therefore 5 times 3 is 15. So I factor out a 5 along with the common factor of x. When you factor, introduce parentheses because, again, a GCF sitting next to parentheses indicates multiplication. If you factor, that's division. That's the reverse of multiplication. So you can always send that back through using the distributive property. 15x squared divided by 5x. 15 divided by 5 is 3. We do division because we know multiplication is the reverse of that. X squared divided by x, well, I'm taking away a factor of x from x squared. So I leave behind one factor of x. And notice that division and subtraction have a relationship just like multiplication and addition. 5x multiplied 3x, 5 times 3 times x is 15x squared. We have our minus sign. Well, here's 5x right here. So I took 5x and pulled it out front. What do I leave behind? I don't leave behind a 0, a factor of 1. 5x divided by 5x, any number divided by itself is 1. So when you factor out, you're dividing out. 5x divided out 5x is 1. So we leave behind 3x minus 1. For a minus 6x plus 2, what could we factor out there? Now this 2 does not have the variable x present, so we cannot, like the first example, or the first part here, we cannot factor out an x here, because there's just not one common here for this term. However, 2 and 6 are both even numbers, therefore they're divisible by 2. So we can factor out a 2. More specifically, as we've talked about before, minus 6x plus 2, this minus 6x has a leading coefficient of minus 6. Because this first term here is negative, let's also consider factoring out the negative sign as well. Not only do we want to factor out that positive 2 because 6 and 2 are both divisible by 2, but because this first term here is negative, let's consider factoring out negative 2. We will see exactly why we want to do that here momentarily. Factor out a negative 2, what do you leave behind? A negative 6x divided by negative 2. Think of it like this. How can you rewrite negative 6x? Negative 2 multiply 3 is negative 6. Multiply our factor of x. So this is negative 6x. We just factored out this negative 2 here. So that negative 2 goes there, leaving behind 3 times x. So as we see, negative 2 times 3x, once again, would simplify down to our negative 6x. So as you saw, this negative 6x became positive 3x because we distributed out a negative. When you distribute out a negative, you change the signs of each term that's being distributed out. So this negative became positive, therefore this positive 2 is going to become negative. A positive 2 divided by negative 2 is negative 1. So our new factorization here, 5x multiply 3x minus 1, subtract 2 multiply 3x minus 1. Ding, ding. Once again, right here, this is why we did it. We chose to factor out the negative 2 because notice what we left behind here, 3x minus 1. That's the same exact binomial that we got over here. This is not a coincidence. This is happening by design. This is exactly how the AC method wants it to work. Because now we see one of the factors that makes up this trinomial is the factor 3x minus 1. It's a common binomial factor, so let's factor it out front. The 3x minus 1 goes out front, and we leave behind what terms here? A 5x, subtract 2. The two binomial factors. And again, are they prime? Can you factor anything out of 3x minus 1? right? There isn't an x here, so I can't factor out an x. 3 and 1, the greatest common factor between 3 and 1 is just 1. So that is prime. For 5x minus 2, the same thing. Look at 5 and 2. 5 is a prime number, 2 is a prime number. I can't factor anything out of that. More so, if you look at the factors of 5 and 2, 5 is 5 times 1, 2 is 2 times 1. You can choose to factor out a 1, but factoring a 1 out of 5x minus 2 will leave behind 5x minus 2. So we didn't change anything because you can always come over here and write times 1. But it's understood that 1 is always a factor of any expression, so you don't have to write it. Therefore, the two prime factors for our trinomial 15x squared minus 11x plus 2 are our binomial factors present. And we can always check this. 3x multiply 5x is 15x squared. Notice that this isn't x times 15x, right? X multiply 15x is also 15x squared. The trial and error method would have caused us to go through all of those possible results. X multiply 15x, 1 times 2, finding those combinations to not work. Our AC method says, follow these steps. Do this every single time, and you will find your correct result. 3x times 5x is 15x squared. 3x times negative 2, well, there's our negative 6x. Negative 1 multiply 5x, that's our negative 5x. Combining to give us our middle term, negative 11x. That's why at the beginning we chose those integers, negative 6 and negative 5, because we see that our correct factorization here will yield an inner product, an outer product of negative 6x and negative 5x. Lastly, of course, negative 1 multiplied negative 2 is positive 2, confirming the correct factorization for our trinomial. Exercise 107. We are told to factor the trinomial 12x squared minus 17x plus 6. First question here, for each of these three terms, is there a greatest common factor? There's 2 factors of x here, 1 factor of x here. There are 0 factors of x here, so we cannot factor out an x. What about 12, 17, and 6? Just to kind of look at those again, 12, 17, and 6. If we think about the prime factorization mentally here, 12 is understood as 3 times 4, but 4 is composite. It can be further factored as 2 times 2. So there is our prime factorization for 12, 3 times 2 times 2. What about 17? Well, 17 is prime. You can only write this in integer products here as 17 times 1. And then 6, of course, 2 times 3. So are there any common factors for all 3 of the terms here present? We notice that there is a common factor of 3 for these 2 terms, and there is a common factor of 2. But there is no factor of 3, nor is there a factor of 2 for 17. So there is no greatest common factor for these 3 numbers. So it's understood to be 1. Because of course we can write all of these numbers here as 1 times 12, 1 times 17, and 1 times 6. All of these represent 12, 17, and 6 respectively. So for each of these 3 numbers, there's always understood to be a greatest common factor of 1. With that in mind, the only way that we now will look for factoring this trinomial is using our AC method or our trial and error method. Let's go ahead and stick with the AC method. First step here is to multiply A and C together. 12 times 6. 12 times 6 is 72. Quick math of that is there are 12 inches in a foot. 6 feet is 72 inches. So nice unit conversions there. So our second step says, can we find 2 numbers that will multiply to give us 72, but those same numbers are going to add together or combine to give us negative 17. We're reversing the FOIL steps, outer and inner product combined through addition or subtraction to give us that middle term. So we want to know, what are those factors that we're going to work with? Well, what factors multiply to give us 72 that add or combine to give us negative 17? If we're combining to give it negative and we're multiplying to be positive, these 2 numbers must be negative. So what are the negative factors of 72? Pause the video for a moment to find all those negative factors. I'll start off. Negative 1 multiplied negative 72 is positive 72. However, they combine to give us negative 73, which is not negative 17, so we cross it out and we move on to the next pairing. What are our next pairings? Negative 2 times negative 36 multiplies to give us positive 72, but they combine to give us negative 38. So we don't want that one. What else do we have? 72 hours is 3 days, therefore 24 times 3 is 72. Negative 3 multiplied negative 24 is positive 72, but that combines negative 27. Negative 4 multiply negative 18, but that combines to be negative 22. Five doesn't divide into 72. It's got to end in a 0 or a 5 to be divisible by 5. What about 6? 6 times 12. But that will combine to give us negative 18. Although it multiplies to give us positive 72, we need negative 17. What about 7? 7 doesn't work. 7 times 10 and 7 times 11 is not 72. 8 times 9, however, negative 8 multiplied negative 9 is positive 72. Negative 8 combined with negative 9 is negative 17. So we found our integers. The negative 8 multiplied negative 9 to get positive 72. Negative 8x combined with negative 9x will give us the negative 17x, which is our middle term. So we found our two integers, and we can move forward guaranteeing that we can factor this trinomial. Using the negative 8 and negative 9 to rewrite the middle term, group the first two terms together, group the last two terms together. The greatest common factor for the first two terms. Look at the coefficients, 12 and 8. They're both even. Can we count patterns here? 2, 4, 6, 8, 10, 12. Okay, patterns of 2, so it's divisible by 2. 3, 6, 9, 12. Okay, so that ain't going to work for 8. 4, 8, 12. 4. And 4 is the largest such. What about the variables? There's an x for each, so we can factor out 4x. Remember, I said patterns because patterns show addition, right? 4, 8, 12 is 4 plus 4 plus 4, but repeated addition is multiplication. And factors are within multiplication. 4x factored out of 12x squared, we leave behind 3x. That's 3x minus 2. For the minus 9x plus 6, can't factor out an x. However, with the 9 and 6, we see a pattern, 3, 6, 9, so we can factor out a 3. Keep in mind, this first term is negative, so not only will we factor out the 3, we will factor out negative 3. Factoring out a negative is going to change our signs for our terms. The minus 9x is going to become a positive 3x, because 3x times negative 3 is negative 9x. The positive 6 becomes negative 2, because negative 3 times negative 2 is positive 6. Again, as we see, this binomial 3x minus 2 matches this binomial. That's what we want by design. If we don't get this, check your work. Make sure you correctly factor, because if you don't get these two to match up, then you have made a mistake somewhere in your calculation. Because again, as we said in step 2, if you can find those two integers that multiply to give you AC, that add to give you B, we found them, negative 8 and negative 9. Therefore, I'm guaranteed for this to factor, and we have it. Factor out 3x minus 2. When you factor, introduce parentheses to see what you leave behind. 4x minus 3. The product of our two binomials results in our trinomial above. We can check this. 3x times 4x, 12x squared. 3x times a negative 3 is negative 9x. A negative 2 times 4x is negative 8x. Negative 2 times negative 3, positive 6. And now our outer and inner product, as we got down here, the outer product and inner product will combine to give us our middle term, confirming that we correctly factored our trinomial into our binomial product 3x minus 2 and 4x minus 3. We know we're completely factored because each of these binomials are prime binomial factors. In other words, 3x minus 2, looking just at this binomial, I cannot factor anything out of those two terms. Looking at 4x minus 3 and only those two terms, 4x minus 3, I cannot further factor out anything from those two terms. Exercise 109. Factor the trinomial 6u squared minus 5u minus 14. So the trinomial here has leading coefficient a equal to 6, b equals negative 5, and c equals negative 14. Going to the board. Multiplying a and c together, 6 times negative 14 is negative 84. Our next job here, our next step is to find two integers. This is step 2 here. Find two numbers whose product is AC and whose sum, how we combine to get negative 5. So we need to think about the factors of 84. 1 multiply 84. 84 is even, so 2 multiply, well, 8 divided by 2, or 4 divided by 2 as well. That is 42. What else do we have here? 3 multiply 28. 28, 56, 64, 84. 4 multiply 21, because 4 goes into 8 twice, 4 goes into 4 once. 5 can't go into 84. What about 6? 6 will go into 84. 6 goes into 8 once with 2 left over. 6 goes into 24 4 times. As we see right there, 6 times 14, of course, is 84. What about 7? 7 goes into 84. Times table is there. 7 times 12. 8 times 10 is 80. 8 times 11 is 88, so not 84. What about 9? 9 times 9 is 81, not 84. It won't be that one. 10, 11, 12, and now I'm at 12. So these are all of our factors for 84. Now it says that they need to multiply to give us a negative 84. So one of the factors here will be negative in our integer pairing here. In other words, negative 1 multiply 84 is negative 84. However, when you combine negative 1 and 84 through addition, we get 83. That is not negative 5. If you switch the two and make 1 positive and make the 84 negative, then combining 1 and negative 84 is negative 83. And it's not negative 5. However, making the 84 negative, we are on the negative side. Because now you see that with the 1 and 84, which number is going to trump the other when you combine? If the 84 is positive, our result in combining will be positive. If the 84 is negative, when we combine it with the 1, our result is negative. So these numbers on this side here, the larger looking of the factors, if we make them negative, then combining them with their counterpart through addition will result in a negative combination. So let's consider the numbers to the right over here to be negative. 1 and negative 84 is negative 83, not negative 5. 2 and negative 42, negative 40, not negative 5. 3 and negative 28, again, 3 times negative 28 is negative 84. But when you combine 3 and negative 28 using addition, this is negative 25, not negative 5. So looking at all these pairings here, 4 and negative 21, well, that's negative 17. 6 and 14, 6 and negative 14 is negative 8. 7 and negative 12. 7 multiply negative 12 is negative 84. A 7u combined with a negative 12u, in other words, 7 combined with negative 12 is negative 5. So we found those two integers that multiply to give us AC, that add to give us B. This guarantees we can factor this trinomial now. Using the two integers 7 and negative 12, we will rewrite the middle term, negative 5u. We will rewrite it as 7u minus 12u. We can also write this as minus 12u plus 7u. That is dealer's choice. That is for you to decide. This is just how I wrote it. Therefore, that's how I'm going to plug it in. But you can switch this if you want to. You are more than welcome to. Rewriting the middle term. We said here we were going to do the plus 7u minus 12u. Again, that's still going to make up this. But now this allows us, because we have it as a 4-termed polynomial, group the first two terms together, group the last two terms together, and determine a greatest common factor for each of the pairings. 6u squared plus 7u. Well, the integers 6 and 7, they're right next to one another. We can't factor anything out of that. 6 is 2 times 3. 7 is 7 times 1. Greatest common factor is just 1, so we can't factor out a whole number. The u squared and u, however, indicate we are sharing one factor of u. Factoring out one factor of u, we leave behind 6u plus 7. Okay, already thinking about the fact that we leave behind the binomial factor 6u plus 7, whatever we factor out of here, we should leave behind the binomial factor 6u plus 7. That's the design of the AC method. Minus 12u, minus 14. So we see already that both of these terms are negative, so we will factor out the negative sign. Also, 12 and 14 are both even integers. They are even integers that sit right next to one another. The pattern there, 2, 4, 6, 8, 10, 12, 14. We can factor out a 2 because that's the greatest common factor. Negative 2 factored out. So the negative 12u is going to become positive, and it is positive 6u. We see because negative 2 multiplies 6u is negative 12u. Negative 14, factoring out negative 2 will become positive 7. Because negative 2 multiplied positive 7 is negative 14. And as we see here, 6u plus 7 is common for both of these terms here. Here's our first term. Here's our second term. This term has two factors, u and 6u plus 7. Here we have the minus 2 and the 6u plus 7. Factoring out the 6u plus 7. Anytime we factor, we introduce parentheses to determine what we leave behind. U minus 2. The product of our two binomial factors results in our simplified trinomial. To check this, 6u times u is 6u squared. 6u times negative 2, negative 12u. 7 times u, positive 7u. 7 times negative 2, negative 14. Again, our outer and inner product combine to give us our middle term, negative 5u.